Hey guys, and welcome to the second video on how to design a stock prediction system using Keras, Pandas, and Scikit-Learn. So if you watched the last video, it took about 50 minutes to cover what I wanted to cover in that video, which includes how to use Pandas, how to plot using Pandas, and basically see how using the available CSV files that I got from Quandl, which is Quandl. Just Google it, Quandl. So that's the site that actually lists some of these CSV files that are stock related and some other finance related database. So anyway, I started with the Bitcoin and worked through a number of them till I got to a point where I showed you how you can plot, see how the change works, like how volume can overwhelm all the other values. So like the number of volumes in the stock are always going to be likely much larger than the price per stock. So you can imagine if you gave your machine learning script that may be a very overwhelming figure. There is something that surely you do with that, which is normalization, where it's just squashing the number so that they don't vary too much depending on that. So your machine learning script doesn't think like the volume is the key to the thing. Anyway, so that was the main reason I was showing you that, just to kind of understand how the data looks and why I'm going to be dropping some of them here. You don't really have to do this. Machine learning is a bit more of an art, so it's you thinking out intuitively. If it was you in this position, told to do this without a machine learning script, just with the right books, the right know-how, how would you do it? And you never get it right the first time, so you try and try again and try again and try again. Your boss doesn't want you to release the final product in a day, so they just want in-house things that does something impressive before eventually they make it go live. So with that in mind, the idea is to make something that looks good enough that it should be working in-house and not scrapped. So it's actually going to be impressive. I hope you're going to wait and see the last version. And with this in mind, I'm actually just going to take you now through what's going to be the final video on how to edit the content, so you have finally the content that you're going to be using for your machine learning script. So okay, let's get to it. So first part is importing pandas as PD, because that's a common thing to do. Import OS, and the next step is for files. This is just getting the number of files that you're going to be using. So this is just called it's called a list comprehension. Basically, it's just running a for loop inside a list, and then it just populates your data inside the list. So for x in os dot list the directory called data. So for everything you find inside this directory, I want you to find anything that only ends with .csv. So basically all files are actually CSV files. So just show you a quick pic of here, which I did show you before. That's not the right folder. This is. So if you look here, there's some finished prediction models and the CSV files. So that's what we want. So I'm just going to do that, and let me just print that. So then I can do print files. So you can see just basically the files I've actually got. And since here I'm actually going to be, let me just create something called new file names. Here we're going to be using these file names. I'll need to put them in I believe the best was just, the above one is called files, but it doesn't have the data folder. So I just have to keep on appending data whenever I'm doing this. Or a simple process is just doing this for file. I could have done it at the first place, but I think this actually makes more sense, so you can see how one thing came from the other. Okay, so for file in files, print file, and then append that file name to this. First it starts with the name data, put an S basically because that's string, and then that modulo sign, then you put what you want to be put inside that string. That's your file names. And just a moment so I can figure what went wrong. The list object is now callable. Files. Okay, let me see what's inside the file. PTC, you see there. That's okay. So oh yeah, forgot to append. Yeah, it's pretty late in the night, so just decided I'm just going to record this right now, so I'm going to be able to post it by tomorrow. So if I do new file names without any typos, yeah, you should be able to see the files that you have here. So if you're curious, how many files do you have here? So just do length of new file names, and I get that in. So I'll know I can do a new file name from 0 all the way to 13 minus 1, which is 12, because it starts at 0, so the last figure is there, the title length minus 12, so we have 12 files to process here. So in this video I'm actually going to try and take the pace much faster, so hope you can catch up. I'll go along with what I'm doing. So what I'm going to do here is just get a new file from new file names position 0, so that's the Netflix file, and then that's just df to head, see what's inside the head, and we have date, open, high, low, close, volume, adjusted, close, and volume. And as I said, you really don't want to put too many rows inside your machine learning script, especially those that are basically the same. Like if you look here, adjusted close and close are more or less the same thing, because adjusted close, the only difference would be if the number of volume was inflated. Basically it's not, it's they duplicated the number of stocks that they're selling, thereby because the stocks numbers have increased, the number has to be divided by the new number of stocks, so that drops the number of price. So that may make price suddenly drop from the close value, but the adjusted close will do the auto correction value. So basically you know what's the actual real change without, if that stock division never happened. So adjusted close is actually more true to the world than close, which is more volatile, especially if this company is in the habit of doing stock splitting, as it's called. So with this one in mind, I'm just going to, I would have done this df.shape thing, but we've already done it with the other video, and I hope you know what that does. So I'm just going to stick to what only needs to be done. Here what I need to do is take only what we are going to be using. So that's open, high, low, close, and volume. Then you may be thinking this feels counterintuitive, because I said you really need adjusted close instead of close, because that's supposed to be the one that's less volatile. But actually what I did eventually do is try and make this as same case for all the different data frames, so they all pretty much look the same. So with this in mind, so now you see what I've done is I've actually not kept these rows, I've actually removed open, high, low, close, and volume. So now we only have date and adjusted close, and the next step is to rename adjusted close to value USD. And in place equals to 2 just says don't make a new data frame and dump out the data to there, just replace this current data frame. So seems to be an issue, set is not callable, df.read name. Okay, let me just have a moment to look at this. Okay, so let me see if I can just figure why it's not working as quickly as possible. So that's df head, that works. So next step is just going to do this exactly from here, cancel out. This should tell me if the way this one has been named is the same. Right, so that works, and I can just shorten this row selection to only the last 5 elements. What I'm trying to do here is rename adjusted close to value USD, and seems not to allow me to do that. So rename equals to column adjusted close. Let's try this with a semicolon. Yeah, okay. It's been a while since I used Pandas, and I actually made this in a soft copy, well, blog article a while back. Then I decided to now push this out as a video. So I'm just going to go through, try and do the same thing that I actually did there. So the next step here is df, the same data frame, create a couple of rows using just that single row. So value 2 is the same as the value USD, and it's shifted up. So what that actually does, if I just show you the first 10 rows, it takes the value here and shifts it up. So basically, like, this is the same as this, this is the same as this, this is the same as this. So if you're looking at the today's value on value USD, which is this, the opposite on value 2 is tomorrow's value. So you can compare today's and tomorrow's value without working with a single row looking down, which is, it's just way more harder and way more confusing, because for example on the first row you may just be wondering, like, how can you compare with the 0 row with -1, which doesn't exist unless you even do something worse and trying to compare with the last value from the last day. One thing that actually does happen with this is when you do a shift and the number of shifts you've done, like here I've done shift -1, so I've only pulled that new duplicate row, which is value USD to value 2, by only 1 position. So when you now check the tail, there's only 1 in the end, which is not a number, which is the same as a blank value. So while we are doing this, we're actually going to create a number of not a numbers, blank values, and that's okay because this data frame is actually pretty huge. Losing just a few rows won't really make a difference. And in reality, if you're working on something like real stock analysis, you probably may even be having something that's more ingrained than this, because this one only gives you per day analysis. You may have something that gives you like quarterly, even hourly analysis of the stock. So losing 5 from hourly stocks analysis, that will make any difference to your prediction model, because if it understands the pattern, losing 5 rows won't actually make it not see the whole pattern. So this one I'm taking the max 7 values in the last 7 days. So let me just finish this so I can show you how it looks like. If I do a df head again, yeah, so this is 7 days. So for us to really get that really well, I'm just going to now get the first 15. The first 6 days or so you actually won't get a price because there aren't 7 days to compare to. The 6th day, which is actually equivalent of the 7th, because this starts at 0, is when you start getting the rows now. And this is basically checking for the last days, these 7 days, which was the maximum value, which if you check here from here, up to here. This is the maximum value, which still stays the same, oh, actually I was checking from this row, so I was wondering where that one came from. So it went from 0854 and then to 0808, so it looks like it dropped down. The reason for this is this one happened here and this one happened below it, so the frame which actually drops, checking from here, which are the last 7 days, it reaches here, so it doesn't go up to position 1. So keep that in mind when you say rolling 7, DF value rolling 7, you're saying you're going to shift a frame of the number that you specified. In my case, I specified 7 all the way down. During that frame, can you tell me what is this in that frame? Like, you could ask for the maximum, minimum, average, anything that you want, you can ask within a rolling frame. And you can also make a function, which you're going to do later, that actually takes that frame, does calculation on it, then returns a value. Okay, so the next one here is the minimum in the last 7 days. So that's same logic. Oh, don't want to make any typos. I had them in the wrong order. So value USD rolling for the past 7 days, give me the minimum value. So df head, and in this case I'm just going to do this. Hopefully I'm not going to make any typos. What I'm saying to Pandas here is, I know you have row columns, and I believe you have row columns with these names, so I only want you to give me the rows that actually have these row names. And same logic, but this time I'm just going to make it only 10. So here we have our value USD and the minimum. So this is the minimum for the last 7 days, which is the first value. Moving down, this one is no longer applicable. You move all the way down, this is now the least minimum, and it keeps the same way all the way. Like, this is a duplicate, but technically you get what I'm talking about. In the last 7 days, which is the most minimum value. Basic mathematics. So mean 7, mean is the same as an average. Give me the last, okay, so just undo that. Give me the average of the last 7 days. So value USD, I want you to roll for 7 days. Keep rolling to the bottom and give me the mean, if you know what I mean. Okay, so date, current value, finally the minimum. And the head of this for the past 10 days. Okay, here basically you won't be able to connect one and the other, but if you basically pick up a calculator quick, pause the video, do your mathematics, you should see it's adding up. That's the value of the past 7 days. And maybe if I try to do that quickly, just to show you this is the case. So this will be df date for the past 7 days, so colon 7 days. Okay, so I take this, turn it into a list. Okay. When in doubt, ask da. And I believe there is a function that actually converts all of this into a list. it's two lists, so df 7 dot to list. So now we have our own lists of the last 7 days, and using this we need to find that average function, which I think I'll have to import from math. Just a simple version is just give me the sum of all of these divided by 7. And I support a type for int and string. Okay, so it seems that all of these all the values are likely strings, not actual digits when they've been converted to list. There is a way of doing an analysis in valid syntax, so yeah. I see where I went wrong. I was actually checking the dates, not the value. So take all that away. So instead of checking the date, all I want is the values for the past 7 days. And here we have 0.69031, which is the same as this. This has more decimal values, which you don't really need. Technically, this is up to 5 point decimal values. And you're talking about currency, up to 5 points. Anything lower than that is negligible. So with that, we move on to creating the next field. So here it's df, looking for the change in the last 7 days. So that's df change, df value, and using df value, it's supposed to be the value st. You minus it, you remove it from value 2. Just check if that's the real name of this field. It's value 2. So it's just checking first row of value sd minus value 2. That tells you the change in the last 2 days, or between yesterday and today. So with that, all I do is just show you now the head, so you can see what's happened here. So 0.421 minus 0.8584, there is a minus. Well, the value actually went up, so that becomes a negative value. If the value goes down, change becomes a positive value because of the order of subtraction that you're doing, because we are taking yesterday's value minus today's value. So if today's value is higher, it's going to become negative, the profit. But if the opposite happens, the value goes down, you get a positive number. That you can do it the other way around. I don't think it really matters, because it just, as I'll show you at the end of this, the machine learning value actually doesn't really know what change means. It just knows that something is going to use to make a prediction. So actually I think if you do it the other way around, follow the same steps and design the model exactly the same way I have, you should get the same high amount of accuracy. So here df need to make mean change, which I hope you can tell is basically going to be for the past 7 days, similarly to the way that I did change for the other values. So it's just a rolling 7, then you get the mean. That's it. So df head past 7 days, check what's been happening with the mean. So the mean, like always, is just what's been happening in the last 7 days. Add them all up and you have your mean, and that gets it from the change value. So with that one, you can actually tell basically roughly, has the change been more negative or more positive. If the value is above 0, it means things actually the other way around, it's going down. If it's a positive, it means things are going up. If it's a positive, things are going down. If it's a negative, things are going out. Yeah, I'm trying to figure it out as I'm trying to move this along as quickly as possible. So df change. Sorry if actually I'm making you more confused, but it's just because I did that the other way around. Another time I was just more interested in seeing how much accuracy I'd get in the whole final output I'd be getting, and it was good enough to actually keep it the way it is. Use that as my final example, push it to GitHub, wrote an article about it. Okay, so here, this is where what I was actually telling you. You can do rolling 7, and instead of asking for mean, max, and so on, you can actually apply and give it a function name. So you're telling it, apply this function to whatever values you've been given. So you get some 7 values. I want you to send them to count drop. It will give you a value, paste it back to that row that basically you've been marking up when you've been dropping it all the way down low. So df drop 7 to that. So unless I actually didn't make this function count, it looks like I actually didn't make this, so let me just make that quickly. So that's def count drop. It just counts the drop off in the numbers, and that's return the length, the numbers that you've been given for x in numbers if x is less than 0. Now the opposite, which is count up, just check for numbers, you return the length of x for x in numbers if x is greater than 0. So count up, count down. If you're looking up, you look up. If it's down, it should not going down. So let me show you what's been going down here now. So now, nope, I forgot to press using shift. So df10 head 10. So the df had 10, and now you can see the drop 7 says in the last 7 days based on change. So on the change values for the past 7 days, how many times have the value been lower than 0? 3 times. You can confirm this by checking from here all the way up. How many values do you have that are less than 0? 1, 2, 3. Right, got it. So same for this one. How many? 2, because yeah, that one doesn't get counted, and so on and so on. You can pause and check and confirm, but it works. So the next one is df up 7. How many times did this go up in the last 7 days? To know that, you still check that very important value called change, because it has been checking for how many changes have been happening. And now you need to apply that to 7 days, and then apply and apply. Under apply, we check for the count up. Then just tell it raw equals true. Can't remember why that was important, but it is. So if you are curious, Pandas has a pretty well documentation online. You can download it as a PDF if you want to. And I'm guessing even if you Google that, there's a 99% chance they'll just tell you why you need to do that. And now you can see up 7, how many times in the last 7 days the price actually went up. So that's 4 times. so on and so on. You may find a point where these two may be exactly the same. That's because there may be a time where change is actually 0. So 0 is not technically less than 0 or greater than 0. So it doesn't fall into any of those buckets. So that value just slips through the seams. If you actually want to find a way to hold that, you just are going to have to figure out between the two functions where you're going to drop it, and then move on to the next section. Now moving on, you do a predict. I want this one to predict how it's going to apply this. What you're going to apply here is a function called the decider, and the decider looks a little bit like what I'm actually going to do below here. So stay tuned while I now show you how it looks. So it's def the decider. Def stands for the def stands for the function. The function, yeah. That's how function actually the defined in Python. So define decider row, and if in this section called drop number 7 equals to, so let me just okay, let me just write a number of lines here so I can just explain it. It becomes a little bit more intuitive because they are a bit longer than the other functions I've been writing. I'd like to make this video still shorter than the other one, because really no one's going to watch a video for 50 minutes and YouTube has so much to offer. So I'm going to do you a favor and try and do this as quickly as possible. So what this function is supposed to be doing is looking at all these rows I'm creating. Drop 7, row up, well, drop 7, up 7, mean change 7 and change. In all of this, what has been happening, give me a value, and the value goes from 2 to -2, and 2 means like, oh, things are going good. Negative means like, oh, things are really going bad. You should be really freaking out right now. So my machine learning model should be looking at this row and seeing like, oh, this field actually says like 2. I can like put my feet up, relax, I'm good. Things are definitely not up in flames. So when this field basically start going on the negative values or near 0, I need to take up, put on my glasses, squint on the screen and try and see what's going on here, technically speaking. But in reality, machine learning scripts usually they usually are way more focused than people are. That's particularly what they do. They can handle a lot of data, look through them, find patterns. They can, for example, if you like think of the major places that have been used for, you can take a video running in HD, it's huge, and it's supposed to look for hundreds of people who may be nefarious, they have some shady background records, and it can pick them out like that. So it just takes a lot of data, does facial analysis in a couple of seconds. Even if you had somebody who was that level of smart, that level of autistic, it may take them, I don't think they might be able to do that quickly, because the machine never gets tired, it never gets sloppy, it never gets even moody, hungry, or any other thing. It, as long as all the parameters are the same, you've provided the same amount of electricity, it's well cooled, and the data isn't coming in a jumbled manner compared to what it's been learning with, you expect a standard expectation of how it's going to be performing. Now, one more thing I'm going to say here is to note this function, I actually did rewrite it a number of times because I thought the values maybe needed a little bit tweaking, like how it was missing a couple of values. I'm not sure if this is my last version of this, but I'll quickly show you if actually it's not that. So what happened is, as you can tell here, there's all these rows that I'm using, only a few of them. drop 7, up 7, mean change, and change. Depending on these 4 values, return me a value as either 2 to negative, which actually now literally it actually goes up to -4. So with this function, let me look if I actually wrote it again with up to -2, because I think that one was a better function between the others. Just a moment. Yeah, because I know eventually at some point I actually squashed those numbers, and then that actually was not the deciding factor. That was just my manual version of a machine learning script. Then later on I made a machine learning script that basically did the same thing and came up with better results, just to see if a manual script could actually come up with a better prediction pattern than all the layers and dense layers that usually make with machine learning script. It's something you have to try, just basically to know, are you really that good? Are you better than machine learning script? So anyway, so we are moving on to the third row, which is if drop row 7 is, this one's actually supposed to be greater than, if row drops. So if you're wondering, I'm just going to be typing as I explain what may actually happen below here. If you're wondering if you actually do miss a number of lines, how would you be able to tell? Well, there is this function that's been put into Pandas that lets you check for NaNs, which basically you've seen here. So I can just look for that whole drop 7 series and say, show me all the rows that actually have NaNs, and I can use that to now see like what have you been missing, then reverse figure out what's been missing there, and boom, now fix that. So that's how I would have done it, and that's how I did it. Just have to wait and see. I think actually this is the right one, because from -2 to from 2 to -4, that looks like it's more than the one I was thinking of 2 to -2, which I think I did the first time. Then I found out that, yeah, there's value sleeping out here. They're never caught by any of these if statements. So I just wrote this, and nothing could basically slip through it and actually get to the other side. You have to get caught by something. So let me just double check and see I actually didn't make any kind of typo here. This one needs to be greater than. So okay, just do quick check over, make sure all the signs are okay. It's equals, and greater than and equals, greater than, less than, greater than and equals, less than. So yeah, they're good. So this one is negative, is actually going to be -1. Now we only just need to do 3 more. So this one is just basically going to be the same thing. I'm just actually going to just copy paste this and change the signs wherever I need to change them. So this one here becomes mean change use less than, and row change use less than also. So you return -2, copy the same thing, paste it here, just scroll a little bit bottom so you can see better. So here just return -3, check the signs, pointing the right way. Okay, and finally the last one, copy, fix the signs, This one needs to be greater than. This one needs to be less than, and that one needs to be less than. Okay. If you're wondering what kind of logic you'll be using to do this, you just need to think like you have these values and you're basically doing a comparison. Is this and this true? So quick best way you know that, just check if you actually missed anything. Otherwise, if you actually are really good in programming and you took the time to actually think through this function that you're creating, 9 out of 10 times you're actually going to make it work. So let me just move this below. If we run it, hopefully nothing bad happens here. So with this, I can just do, I want to see the value for value USD on the row called predict. The check I'm going to be doing is if any of this is null. So I just want to see the null values in this. And I think the best way we would have done that is to just take this and try it. Put a df here, turn this into an expression. Yeah. So I looked into it, and this is how you actually do it. I just use df inside the data frame. You check for the predict column, check is any value null, and that gives you a true or false value, and then you filter with that. And as you can tell here, there is a lot of false values in this field. 516, which is a lot compared to the total, which is 2959. So what I did is I went ahead and edited this to something I found later on from the blog article. I think there was just some couple of equations that I actually did miss with that one. Did it again, same thing. I apply the predict value, just basically so you have a simplified data frame that checks whether any field in the predict value is actually blank, which is not a number, and we got 0, and we're basically 1, which is the last value, which is, if you use df to tail 1, which just returns the last value from the bottom, shows you this is the case. And that's understandable because most of this value are actually not a number. And in this case, I'm okay with it. The value just doesn't have anything to compare anything to. So one more thing I want to say with this one is, this is not a rolling application. This actually compares per row. So on that row, it checks the drop, row up 7, mean change 7, and change 7. So unlike a rolling, if you check now with an example which actually has all the data, just going to do a df here, head of maybe just 5, the original. You can tell here that -2, -1, 1, 2, and so on. And that let me just change this to 10. And that gives you all the data that comes in this row. And with that, you have the simplified version of how you make this. Simplified because I'm just going to try and run through all of these, show you how it works with one. And I'm just going to basically show how I'm going to do this with one, not do it for the others, because the process is basically the same thing. And then I'll just show you with the edited versions of this. Okay, so with this one, now we have the df.head. The next thing to check is the predict version that you've done. Check the null values, and now one thing you may be interested in knowing is the distributions of the values for the predict row. How many zeros are there, how many ones are there, and so on. So to do that, you just do df.predict, check for the value count of these fields. Okay, so this in mind, I think I just don't need to put double braces, so just use one. Yeah, that works perfectly. So you can see we got 0, 1, 2, -1 and -2, and my hunch was right because it seems -3 and -4 never match up anything. In my scenario, maybe in a different data frame they actually do match up with something. I don't think they will. And with this, you've actually made one of the models that we're going to be using with our machine learning script. So df the columns shows you all the columns that exist, and the only column here I'm going to drop is value. So it's using drop df drop. Yeah, column name is value2, inside a string, so that's value2. The axis is 1, just means check the column name, not a row with actually this value, and in place equals to 2. So it's actually going to edit this in place. So if I now check head again, value 2 will be gone, and that's okay. So with that, just do df.toCSV, and for simplicity's sake, I'm just going to do a new file name. File name is on the beginning, which would be this. So just take this, copy this, paste it back, and just add an editor to the end. And with that, we've made a model, a CSV model, which you're going to be using in the next episode. So with that, you can tell BTC USD edited has been created here. I'd already gone before and previously and created all of these others, and since the methodology of creating this is the same, we just need one value, which is the value of the stock. Everything else I'll ignore, even if there's an adjusted clause and so on. You can choose to use the value if there's only the value. If there's an adjusted clause, I'd recommend you use the adjusted clause value, because that value is actually less volatile, and the value at the end of the day feels more useful than the value at the beginning of the day. And with that, that concludes this video, and thank you for watching.